Welcome to Star OMOP Tutorials. My name is Priya Desai and I am the Research and Development Manager for Biomedical Informatics here at Research IT at Stanford Medicine. This is part 2 of Tutorial 3. This particular video we will explore the main Atlas paradigm, and we'll also talk a little bit about generating cohorts. I do want to again remind you that we also have a lot of the Odyssey Atlas tutorials put out by the Odyssey Consortium, and I really urge you to watch those as well. So there are a few of them in there that actually walk you through how you could create concept sets and cohorts and so on. In this video, I'm actually going to discuss some other ways of creating cohorts other than from first principles, which is what is shown in the Odyssey tutorials. All right, so the important thing to realize about Odyssey and Atlas is that Atlas is just one of the open source tools that Odyssey offers to support various data analytics use cases, on observational patient level data. So the thing that all of these tools that they have created and are available open source, what these tools have in common is that they all interact with one or more databases using the same underlying common data model. And so what that means is that these tools kind of standardize the analytics for various use cases. So rather than having to start from scratch, an analysis can be implemented by actually filling in a standard template. And what this means is this really makes, first of all, performing analysis is easier. It also improves sort of your reproducibility and transparency. So it really allows you to share the exact methodology that you used, the exact parameters that you use, the exact definitions that you use with your colleagues, and it really makes, it really is, this thing's the wheels for reproducible science. So, for example, there could be maybe almost an infinite ways to compute an incidence rate. But all of these you can specify in the Odyssey tools with a few choices. And then anyone who makes these choices will compute the incidence rates in exactly the same way. So before you actually go on to doing analysis, one of the building blocks that you need is actually to be able to create concept sets, which I will not discuss here, which is there in the list of Odyssey tutorials, and actually then go on and define your cohort. So there are two main ways of defining cohorts. There's a traditional way, which is rule-based. So it really is based on, SQL code. It's a deterministic algorithm. And that's the one that we're going to discuss in this video. There is also a probabilistic way of defining cohorts, which really uses the likelihood of belonging to a cohort. This is done really well in another amazing Odyssey tool called Aphrodite, but we're not going to talk about that in this video. Whoops. So I guess I gave that answer out already. Okay, I see what happened here. I guess it went straight to the answer that was last recorded when we used this particular poll EV slide. So the question is, under the definition of a cohort as used in the Odyssey community, the following are true. One person may belong to multiple cohorts. One person may belong to the same cohort for multiple different time periods. A cohort may have 0 or more members. One person may not belong to the same cohort multiple times during the same time period. All of the above, some of the above. So the answer to this actually is just all of the above. So all of the following are true for or can be true under the way a cohort is defined in the Odyssey community. Note that this may be different from how it's actually defined in some other areas of biomedical sciences, depending on how you're defining your cohort or how you're actually running your study. But if you're doing it in the Odyssey community, if you're actually using the OMOP data model, these 4 facts are true for every and any cohort. Okay. All right, so yes, the consequences of this definition is one person may belong to multiple cohorts, one person may belong to the same cohort at multiple different time periods, and so on. And the important way that this definition is different than many of the, than the way a cohort is defined in many other departments is that just a list of ICD codes is not a cohort. There has to be a logic on, on how do you use that code set, and there has to be an input and exit criteria. So a cohort contains, it contains the list of codes, but it contains input criteria, like what events need to have happened for a person to enter the cohort, and when does a person exit the cohort. So there's always a time period associated with a cohort, and that's really, fundamentally how cohorts are different in the Odyssey world. So the building blocks for creating cohorts are, you need to know what conditions these patients may have had, the drugs, procedures, measurements, observations, and visits. And there are a couple of different ways of getting a cohort definition. I mentioned that earlier. So one is from first principles, which is really you develop your cohort step by step. And this is demonstrated really nicely in the Odyssey Atlas tutorials. The other way, and this again speaks to the fact that, remember we said you could actually share your cohorts, you could share your analysis methods, so you could actually get it from another colleague in the Odyssey community. And remember we said every institution has their own independent atlas. So for example, your colleagues in Columbia cannot look at your Stanford atlas. However, there is a public instance of Atlas, and you could develop your cohort, or you could export your cohort definition there, and from there your colleague anywhere in the world could actually get it. So what I'm going to show you in the rest of this video is actually how you could import cohort definitions, say from the public Atlas instance, and also how you could actually import the definition of a full-fledged study from the public Atlas instance. So the main way that works is essentially it's just a copy and paste. So if the study was specified and run in Atlas in a JSON file with the full specification, it can be copied and imported onto a local Atlas instance. And we're going to use this Atlas public instance, which is what you use to share the definitions in the community. The studies, the network studies, are also in the GitHub, and that's another place you can actually get them from. There's a special Atlas instance, this last particular one, atlas-covid19.odyssey.org, which specifically contains COVID-related definitions that have been, definitions of cohorts that have been generated specifically for COVID. So, whoops. Okay, so let's actually get started. Let's go to, we're first going to, I'm going to demonstrate a way to actually import a cohort from the public instance into the Stanford instance. So I'm going to first go, I already have a tab with the Stanford instance. So this is the Stanford instance. I'm actually going to also open the public instance. Okay, so that's the Atlas public instance. I'm gonna just move it here. Okay, and here I want to import a new cohort definition. So I'm just gonna go to cohort definitions. Sometimes you'll find, depending on what all you've been doing in Atlas, that you want to generate a new cohort instance, but when I go to cohort instance, or I go to search, it doesn't look like I can actually create a new cohort. So what you typically need to do, and often what fixes it, it's just hitting reload. So just hit reload real quick. All right, so now you see that this tab is now clickable. So go ahead, click new cohort. Go to export. I'm going to actually get the JSON export. So I'm just going to go to the JSON tab here. So right now I haven't exported anything. I've just got this ready. Okay. Now I'm going to go to the Atlas instance from where I am going to import a cohort definition. So let me go to that instance of Atlas. So this is the demo instance. I go to cohort definitions and I'm just looking at cohort definitions. I can pick any one of these. So let me just go with this, cohort definition 1776174, statin patients. So let's see, it says it's a drug era of cholesterol patients, and cholesterol seems to have, okay, so these are the names of the drugs that this one includes. Okay, so this I think seems like a legitimate cohort. Let's see, does it have concept? Okay, so it does have concept sets. Okay, this concept set has a bunch of drugs. These has a bunch of more drugs. All right, just for sanity's sake, let me just make sure that this is a legitimate cohort. So you can just, this is the demo instance that I'm in. So this is the SynPub dataset, but just as 1,000 patients. So it's really small, but it's enough for you to verify that your cohort makes sense. It can actually really generate a set of patients. So you can see I actually just ran this a little bit before, a few minutes ago, but I'm going to go ahead and generate it again. So I would recommend that before you import any cohorts, go ahead, generate the cohort, make sure that you actually get some real people in that in the SynPub dataset. I mean, it's not always the case that you will, because the SynPub is an administrative claims dataset, and remember, it's a completely synthetic dataset. But for most cases, hopefully if you get a few people, then it's a legitimate cohort. So assume this is the cohort I want. So so I know this is the name of the cohort that I want to get is statin patients. And I know it's a legitimate cohort, so I'm going to now go to the export tab. And in the export tab, there's a text view. There's a really nice graphical view. Hopefully it will load. Okay, this is not the best example of the graphical view, but it really shows you a nice graphical view of what's the start date, end date of when they can enter into the cohort. And so on, in a lot of cases where you have more complex time-related events. But yeah, let's go to the JSON file. Okay, so this is the JSON file for this particular cohort. And you can see that all the concepts are in here. All right, so what I'm going to do is I'm going to copy to clipboard. So I've copied it. And now I'm going to go back to my Atlas. I have to give this a name. So I'm going to say PRD statin patients. And I'm going to say test. I actually want to copy that here. So I'm going to go ahead, copy this, whoops, delete it. There's nothing here. And I'm going to paste this. So I've pasted the definition that I had copied from here in here. So let's just make sure that's what we have. So you can see I have it. Whoops. You can see I've copied it. Okay, so I'm now going to just hit reload. Okay, so it's right here. Whoops, no. Yeah. Okay, so here I have the cohort, the cohort definition in JSON copied over here. And at this point, it's really important to do this. You need to click save. And now this cohort has been saved. As you can see, I have this definition. It's the same as what I have here. So I have this definition, except it's now called PRD, Statin Patients Test. And now if I actually go back to cohort definitions, you can see, I can see it as a cohort. So that's how you would import a cohort definition, from a colleague, say from a different Atlas instance. You would do the same thing if you actually wanted to copy a cohort definition from another colleague, even within Stanford. Because sometimes what you want to do is you want to use somebody else's cohort definition as your baseline, and then you want to modify it further. So, for that case too, you can start with somebody else's cohort definition and then go ahead and modify it. So to do that, this is a good way to just import it. The other thing that I wanted to show you guys how to do was actually to show you how you can actually do a patient level prediction study. So let's try to import a patient level prediction study. This is a patient level prediction study I had just imported a few minutes ago, but let's try to do this again. The one thing I wanted to show you that is really neat is that because this patient level prediction is owned by me, I can actually go ahead and delete it. But you can't delete anybody else's cohort definition or study definition or anything, right? You only have an ability to delete your own cohort definitions or concept sets or patient level estimations, prediction level, patient level predictions, incidence rates, anything that you have generated, you have the control to delete, but you can't delete what somebody else has generated, and that's really good and that's really fair. So anyway, let's so as you just saw, I just deleted the one that I had created. I'm gonna go to cohort definitions here. No, I'm gonna go, so I'm back at the demo Atlas instance. I'm gonna go to prediction. I wanna use a PLP study that I know is a legitimate study, and I know the WU study, WU is Women of Odyssey, these were real studies, real network studies that were done in 2019. So I'm gonna just take one of these, and I'm going to, so you can see it's a legitimate study. There's a target cohort, there's an outcome cohort, there are model settings. You actually set the model type, you set the parameters, you set the covariate settings. This is the problem level settings, so the analysis settings. You set the covariates, and you can actually, these are the execution settings. You can actually, on the Stanford Atlas, so this is the demo Atlas. On the demo Atlas, you can review and you can download this definition and then actually import it into your R environment, your Odyssey R environment, and actually run the study. But in the Stanford instance, you'll notice that there is another little tab, another button where you can actually execute it. So the Stanford Atlas instance allows you to execute, any of these network studies. But you can definitely import this one. So let's go here, let's go to export. That's what I want to do. And again, I do the same thing. I just copy to clipboard. And then I go back to this one. I say new patient level prediction. I go to import. Whoa. And now I've imported this. I've copied it. So I've copied it. I haven't really given it a name. I haven't done anything here, but I'm going to just copy this. And I'm going to just, and I'm going to just import it. and you can see that it imported even the name. So it imported everything. And now at this point, I can go ahead and call it something else, like and you will see I have everything. I have the problem level settings, I have the analysis settings. You can see that the model settings are the same variance. I'm going to come to that in just a second. So first thing is we need to save it. This is really important because if you don't save it, you know, it'll disappear next time you come back here. So go ahead and save it. All right, so now we've saved this. And so now if I come back to, if I close this and I come back to prediction here, I can see the WU 2019. This is the study I just imported. And I go click it. Now you'll see that if I go to executions, I actually get this particular view. This is not available in the Odyssey demo atlas. And now I can actually execute the study on, you know, any one of these data sets, depending on what you have access to. So you can go ahead, click generate. And we've run most of these studies. We've run it using the Atlas instance, this Atlas instance, and you should be able to do that yourself too. So I hope this was helpful. Thank you, and I will see you guys next time. Okay, bye.
The preceding program is copyrighted by the Board of Trustees of the Leland Stanford Junior University. Please visit us at med.stanford.edu.